Consider a scenario in which Reapers are scheduled to arrive at times given by a specific formula. Each Reaper's job is to kill you if you are still alive at its appointed time. If you have already been killed by an earlier Reaper, the arriving Reaper does nothing. In the standard way of describing time using real numbers, the sequence approaches 0 as n increases, but none of the times is actually 0. This means no Reaper is assigned to act exactly at time 0. Consequently, there is no single Reaper that can be pinpointed as the ultimate killer. The paradox arises with the question, who killed you? Because although you must be dead by the limit of this sequence, no specific Reaper seems to deliver the final blow. A proposed resolution uses a renaming scheme based on the two-adic number system. In the two-adic framework, closeness is determined by divisibility by powers of 2 rather than the usual distance on the real line. One way to carry out this renaming is through the reciprocal mapping. Applying this, the sequence grows without bound, so it does not converge to 0. However, in the two-adic metric, the two-adic absolute value of 2 to then is given by 2 to the minus n, which goes to 0 as n goes to infinity. Thus, under two-adic norms, the sequence converges to 0, meaning the limit becomes part of the two-adic closure of the set. In the real number approach, 0 is only an abstract limit that no single executioner ever reaches, so there is no final event at that time. In contrast, the two-adic viewpoint naturally includes 0 as an actual point in the transformed sequence. This perspective allows the limit to be assigned a specific label. As the sequence progresses, the later executioners effectively merge into one infinite limit, because beyond some point, each one is performing the same role at closer and closer intervals. In this way, the merged limit is given a concrete identity, often called executioner 0, corresponding to the two-adic 0. This label represents the cumulative effect of infinitely many executioners acting at ever finer intervals of time. Under this renaming, the gap at 0 disappears because the limit is now a labeled part of the sequence. In other words, the elusive final executioner is identified as executioner 0, who embodies what was previously just an unreachable boundary in the real number model. This does not change the underlying fact that infinitely many executioners act in finite time, rather, it reframes the process so that the limit point is no longer outside the sequence but instead included within it. In this way, the renaming scheme offers a formal way to say there is indeed a specific executioner who delivers the ultimate blow, resolving the paradox by transforming an unassigned limit into a named, final event.